Hey guys, in this next video I want to continue taking a look at how we can factor polynomials. In the last video it was binomials that we focused on, and then in this video we'll review how to factor trinomials and four-term polynomials. So for trinomials, again, you always start out by looking for a GCF. So if you look at number 1 here, n to the fourth plus 2n squared minus 24, we see that there's no GCF. So then we'll start by doing one of two things. We can either factor this like a normal trinomial, or if the leading coefficient is anything but 1, then we try sliding and dividing. Since the leading coefficient here is 1, then we'll just factor this into two binomials like normal. Now, previously we've only factored quadratic trinomials. Here you notice that this is a quartic, but the process works the same way. You have to think, what times itself will give you n to the fourth? Well, that would be n squared. So n squared is going to go here and here. And then what two numbers would multiply to give you a negative 24, but combine to give you a positive 2? Well, that would be a positive 6 and a negative 4. 6 times negative 4 is negative 24. 6 combined with negative 4 is positive 2. So if we were to FOIL this out, we would get n to the fourth plus our 2n squared in the middle minus 24. So this is how we factor this trinomial. But if you notice, we're not done yet, because right here we have a difference of squares. N squared minus 4 can be factored further into n minus 2 times the quantity n plus 2. So you always need to check those binomials. If they're not linear binomials, check to see if you can factor them either with a difference of squares or a sum and difference of cubes. So this right here then would be our final answer for number 1. Okay, number 2, I see a GCF of w that I can factor out of this trinomial, so I'll do that first. That leaves me with w squared plus w minus 20. W squared plus w minus 20 is what I consider a normal trinomial, meaning it's going to factor with a w as the first term here and here, and it would be a w plus 5 times a w minus 4. Bring down your GCF, and that's all we can do with number 2. Number 3, the GCF of this one is 2a, so factor that out. You're left with a squared plus 19a plus 34. And then that trinomial is going to factor into a plus 2 times the quantity a plus 17, with your 2a being brought down. Number 4, there's a GCF of x that can be factored out. So you're left with x to the fourth minus 24x squared minus 25. So here, you're going to factor this with binomials that start with x squared, sort of like number 1. Two factors of negative 25 that combine to get negative 24. Well, that would be a minus 25 and a positive 1. And again, bring down your x as the GCF. Look for differences of squares. We do have a difference of squares here. X squared minus 25 factors into x minus 5 times the quantity x plus 5, so we can factor that further. We cannot factor x squared plus 1 because that's a sum of squares, and sums of squares don't factor, so that just gets brought down, as well as the x. So this would be your final answer for number 4. Number 5, for this one there is no GCF, and the leading coefficient is not 1, so this is a slide and divide problem. I'm going to slide my 3 over and multiply it by negative 5, so you get x to the fourth plus 14x squared minus 15. Factor this as you normally would. This would become x squared plus 15 times the quantity x squared minus 1. But because we slid this 3 over, now we have to divide both 15 and 1 by 3. So that gives us x squared plus 5 times the quantity. This would be x squared minus 1/3, and so we can rewrite that as 3x squared minus 1 by sliding that 3 in front of the x squared. So now I have no differences or sums of squares, and this is factored completely. Okay, number 6, 9m to the fourth minus 12m squared plus 4. No GCF for this one. So again, slide your 9 over, and this becomes m to the fourth minus 12m squared plus 36. Negative 6 times negative 6 is positive 36, and then negative 6 minus 6 is negative 12, so that's how we would factor this. Remember to divide by the 9, so that becomes m squared minus 2/3 times the quantity m squared minus 2/3. And we would rewrite that without the fractions. That would become 3m squared minus 2 times the quantity 3m squared minus 2. Or you could write it as 3m squared minus 2 quantity squared, since those are both the same factors. Okay, so that's a review of how to factor trinomials. 4-term polynomials, to factor those, we use the box method. And in order to use the box method, remember from last year, you have to check first to see if the product of the outer terms is equal to the product of the inner terms. So for number 7, x cubed times negative 9, that's negative 9x cubed. And then the middle terms, negative x squared times 9x, is also negative 9x cubed. So because those products are equal to each other, we can use the box method for this one. So I'm going to put my first term in this upper left box, x cubed, my next term in the upper right, my third term below in the bottom left, and my constant term down in the bottom right. And I'm going to factor GCFs out of each row and each column. So my first row, my GCF would be x squared. My second row would be a plus 9. Remember to follow this sign here for this GCF. In my first column, x cubed and 9x, the GCF is x. And in this column, it's going to be a negative. Make sure you follow this sign. And the only GCF you can take out is a 1. So this factors into x squared plus 9 times the quantity x minus 1. There's no difference of squares. There is a sum of squares, but that won't factor, so this is your final answer. Okay, number 8. Again, check to see that you can do the box method. You get a negative 5k cubed when you multiply the outsides, and then also a negative 5k cubed when you multiply your inner terms. So you can do box method on this one. And I'll tell you, just for these notes here, every single one of these you can use box method on, so I won't be checking the rest of them, but always be in the habit of doing that, just in case. Okay, for your top row, the GCF would be k squared. For the bottom row, again, follow this sign, so it would be a minus 1. And then for the first column, the GCF would be k. For the second column, follow the plus sign here, it would be a plus 5. So this factors into k squared minus 1 times the quantity k plus 5. And then this binomial you can actually factor further because it's a difference of squares. So this becomes k minus 1 times the quantity k plus 1, and then your k plus 5 still comes down at the end. Okay, number 9. Check for a GCF first. We don't have one for number 9, so we'll go ahead and set up our box method for this one. (4v cubed minus 5v squared minus 16v plus 20. For the top row, the GCF is just v squared. For the bottom row, it's going to be in minus 4, GCF of 16 and 20. For the left column, the GCF would be a 4v, and for the right column, it'll be a minus 5. So we have v squared minus 4 times the quantity 4v minus 5. V squared minus 4 is a difference of squares, so factor that into v minus 2 times the quantity v plus 2, and then 4v minus 5 would come down. This would be your final answer. Okay, finally, number 10. No GCF for this one, so again, we'll set up our box. 2x to the 5th minus 18x to the 4th plus 7x minus 63. Your GCF of the top row would be a 2x to the 4th. Bottom row would be a plus 7. Left column, this would be just an x, and then this column here would be a minus, and you can factor a 9 out of 18 and 63. So this becomes 2x to the 4th plus 7 times the quantity x minus 9. Okay, if you had any questions over this video, make sure you have those written down so that you can ask those the next time you're in class. Until then, have a nice day. You're all wonderful people. Take care.